Um, I'm today's speaker, Zhiyang Deng. So I'm currently a fourth-year PhD candidate in financial engineering at Stevens Institute of Technology, and I'm very glad being here to present our recent work at FinCon, a synthesized LLM multi-agent system with a conceptual verbal reinforcement for enhanced financial decision making. And this is work with my colleagues at Stevens. So the main author here, Yang and Zhiyang, who are the people who lead the whole project, and Hao Hang and Yue Chen, they make a lot of efforts for the data preparation and also the code formalization, and Yupeng and Zhichen, they are responsible for the experiment. So this is a very huge project, and we also received the contribution and the valuable advice from the Jimin at the FinAI and also the Guo Jun from the Harvard University. So since this is a very short presentation, if you are interested in the details of our work, you can access this archive preprint link. So let's start. Okay. Okay, so my presentation basically have 5 parts, and firstly, I will give a short introduction to our motivation, and secondly, I will give the innovations about FinCon's design, and also I will give spend most of time to introduce the methodology of FinCon, and also I will show the experiment results of our model, and finally I will give it some conclusion of that. So to begin with, let's see, the large language models has demonstrated notable potential in complex texts and increasingly utilizing the various financial applications. However, as the most important financial applications, investment decision making is still, it remains a challenging for the LLM-based agent to make high quality sequential financial investment decision making. So basically, in the literature, has 4 parts of unaddressed challenges. The first, in the literature, the single agent designs usually fails to control the overall risk over very long-term trading periods. They only focus on the very short-term risk, control the short-term risk exposures, which is a very huge issues in the trading tasks. And also, some single agents show the very limited adaptability to other financial applications involving multiple assets, such as the portfolio and portfolio management. And our work is the first paper, is the first work to let the LLM-based agent to deal with the portfolio management. And also, since most of literature, they focus on the single agent design, which places heavy pressure on the language model. And we know a language model typically has a limited context window. So basically, this constrained the ability of an LLM-based agent to do such kind of decision-making text. So even though there is a literature to propose the multi-agent design for the financial trading tasks, but their work suffers from the ambiguous optimization object and is unable to control the non-necessary peer communication costs. So in order to try to solve those unaddressed challenges, we propose the FinCon, which is a large language model based multi-agent framework for both single stock trading and portfolio management. And for the first issue, long-term risk exposure control, we propose a dual-level risk control component to deal with such challenges. And the inability of portfolio management of traditional single agent design, we introduce some external portfolio optimization solver to deal with such kind of issues. And in order to solve the heavy pressure on single agent, FinCon is actually a multi-agent system. And unlike the prior proposed multi-agent system, the peer communication costs and unclear optimization goal is solved by the synthesized manager-analyst hierarchical communication structure. So let's go into the details. Okay, so for the methodology part, we firstly modeled two financial trading tasks as partially observable Markov decision processes, POMDPs. So which provides the multi-agent system with a synthesized optimization objective function. And then we show how the FinCon system solve this optimization problem via unique verbal reinforcement method. So which is a prompt engineering technique without fine-tuning the language models in intrinsic parameters. And this is a general framework of the FinCon. So at the first part, we need to multi-module marketing environment informations, which include the textual data and also the tableau data and also the audio data. So after we use this data, after we get the data from the environment, we can pass those data information into the FinCon systems. So since we are agent framework, so actually we can actually replace the LLM core by different language models like the GPTP, like Llama. And after we pass it into the FinCon systems, the analyst, the data analysis, the different analyst agents will deal with those multi-module information data. Then they will summarize some investment insights to pass them to the trading manager agents. Then trading managers agents will use the risk control component to do the correct investment decisions. So basically, this is the general framework of the FinCon. And now we can give a modeling for the trading texts. So basically, the FinCon uses analyst group and agents group to process the multi-module market information source. And the processed information is then used by the manager agent to make trading decisions, which is called action. And additionally, the FinCon evaluates the daily investment risk followed by the prompt optimization for the manager agent from the risk control component. So for the single agent trade, this is a table here. For the single stock trading, action is defined by for such tasks, action is defined by the sell, buy, sell, hold. And in our work, we also allow the short position, which means your asset position can be negative number. And for the portfolio management among N assets, the action is actually given by a mean variance optimization. So the FinCon is going to use the external optimization solver to solve such mean variance optimization problems. However, the large language model agent will get involved in this constraint part. So the LLM-based agent, they will give the action for each asset. So at each day, the manager agent is going to decide the buy, sell, hold signal for each trading stocks. Then this trading decisions is going to be reflected into the optimization problem constraints. Then the manager agent is going to solve this solve this optimization problem to get the portfolio weights. Then the targeted trading position is going to be calculated by linear scaling the portfolio weights to gather from these steps. So basically, can see, or we can see for the portfolio management tasks, the action is decided by the optimization solver results and also the manager agent decisions. So that's the rough mechanism for the FinCon actions. And to save the mathematical notations, we only give the optimization objective. So the FinCon multi-agent systems is supposed to learn all the policies of all agents, including analyst agents and the manager agent. So the all policies are actually parameterized by the prompts. So this is different from the traditional reinforcement learning. Okay, so those prompts are textual, the textual data. So basically, we parameterized those policies by using textual data. And by updating those prompts via risk control component, the whole systems optimize the policy theta, the pi theta in a verbal reinforcement manner. So by denoting the daily profit and loss P&L by RT, then the optimization objective for the whole system can be written like this. So basically, this is very similar. It looks like similar to the traditional reinforcement learning, but however, we are doing the verbal optimization of this objective. So this is a risk-sensitive optimization problem with respect to textual gradient descent, which is essentially different from the traditional gradient descent algorithm. And we will explain this in next slides. So in a large language model based prompt optimizer, so a meta prompt is actually used to refine the text prompt for better performance. So for example, for the mathematical reasoning text, a task prompt might be, let's solve this problem. But meta prompt could be, please improve the prompt to help model better perform the mathematical reasoning. So this is different. And the textual gradient descent is based on the meta prompt. Okay, so the FinCon, in one word, the FinCon solved the POMDP objective 1. So the objective 1 here is this one. So this function. So solve this function via textual gradient descent. So for revising the meta prompt, so which mimics first the optimization process direction, G, and also the learning rate as follows. So it looks like the traditional gradient descent, but actually they are essentially different. So firstly, by generating the feedback from the past success and failure on training decisions, which will be summarized as the conceptual perspectives, the large language model optimizer, MR, can produce the semantic gradient signals, guide the optimization directions. So this is actually, the optimization directions is given by the textual information. Okay, it's not the real vector, it's just the textual guidance. And so to mimic learning rate effects, we measure the overlapping percentage between the trading decision sequences from the consecutive iteration. So, for example, like we are on the second and third training iterations. So we compare the trading decision generated in these two iterations. Then we calculated the overlapping percentage between these, two sequence of actions. Then we use this overlapping percentage as the learning rate, Okay. And then we added the previous task, a meta prompt to enhance the prompt performance. So here, this minus here is actually meaning we added the old meta prompt and to make it to get the new updated one. So the meta prompt instructs the large language model to modify the current prompt based on the feedback ensuring a stable and incremental improvement process. Okay, and usually this high learning rate meaning we need to give a very huge changes in the meta prompt, and the small number on the a small number in the learning rate, which means we need to get a huge revision of the meta prompt. But a large learning rate means we can only get we only need to get a minor change in the meta prompt. So that's for textual gradient descent. And this is the basically the detailed framework of the FinCon structure. So as you can see, first we received the market information, which include stock process, financial news, and the 10K and 10Q company report, and also this like the investment research reports, and also the ECC audio recording. Those multimodal information. Then those modal information will pass into the analyst group, just like the trading firm. Okay, so the stock selection agent is going to be is going to select the target, the asset pools, and those data agent will exclusively just dealing with one information source. Then they will summarize those information as some investment related insight, then pass them to the management agent. So the manager agent is going to make such trading decisions based on those insights. And during the daily trading, the manager agent is going to use the conditional value at risk to control the daily trading risk. And then for the overall training iterations, the over episode risk control is going to be updated. The manager investment beliefs via this conceptual verbal reinforcement and also the textual-based gradient descent. So we use these two mechanisms to control the trading risk. Then this action is going to be passed to the financial environment, and the environment is going to give a reward, like which is the daily trading profits and losses P&L, and this feedback is going to pass to the manager agent, and the manager agent is going to reflect the trading results based on the reward. Then they will the manager agent will pass those conceptualized feedback based on the significant investment insight. Then such feedback will pass to the analyst agent group. Then analyst agent group will improve the way to process the information, because the analyst maybe lose some valuable information when they deal with those, the raw information source. But such conceptual feedback will help the analyst agent to improve their way to process the information. Okay, so basically this is the structure. And so in the FinCon, the analyst agents is going to distill the concise investment insights from the large value of multi-source market information for one specific trading target. So which means this one specific trading target is to increase the P&L, increase the cumulative return. Okay, and also the analyst agents support the manager agent in making informed trading decisions by consolidating the denoise investment information from the multiple perspectives. So this is the responsibility of the analyst agents. And also in the FinCon, the manager agent is the sole decision makers. So who generates the trading actions for sequential financial tasks. So the manager agent is consolidates the distilled investment insights from the multiple analyst agents, and he or she will also receive the timely risk alerts. So the risk alerts is triggered by the conditional variable risk, and also it will receive he or she will receive the conceptual insights updates from the risk control component. And the manager agent is also able to refine the investment beliefs about the impact of the various information source, and it will retrieve self-reflection based on the reasoning outcome of the previous trading actions. So basically, this is the synthesized structure. So the analyst will follow the order from the manager agent, and the manager agent is the sole decision makers. But however, the manager agent will provide some improvement advice for the analyst agent to help them to do the better job. So this is like a hierarchy structure design. So such hierarchy structure can dramatically decrease the communication costs. So everybody they behavior like in a synthesized way. So and for crucial part for one crucial part of the FinCon design, which is such risk control component. So risk control component has two parts. The first part is the within episode risk control, so which is responsible for the risk alert on daily trading. So this is actually it's triggered. So this risk alert is actually triggered by the instant job in the conditional variable risk, because conditional variable risk typically represents the tail risk of your trading behavior. So once it drops, it often means the P&Ls from your previous trading decisions are in the bottom 1%. So which means you make some such big mistakes in the tradings. So which will alert the manager agent to do the reflections. However, since the training the training stage of our model can include multiple episodes. So we also include the over episode risk controls. So in the over episode investment beliefs updates facilitate the timely adjustment in the way of analyst information distillations and also the management generations. So basically, this triggers manager agent to update the investment beliefs. So such reflection is based on the reflecting on continuous winning and losing actions, and also the manager agent will compare the conceptualized aspects of the investment insights from both the more profitable and the less profitable episodes. So basically, it has two parts, and in one word, this over episode risk control can help management agent and analyst agent to update their investment belief. So these two mechanisms can help FinCon to control the overall risk. And now we move to the single agent design. So since this is a multi-agent system, we need to give a general design for the agent. So the detailed modular design of the manager and analyst agents. So it has 5 parts, like 5 parts. The first is the general configuration. So the general configuration usually include the investment text introduction and also the trading target background. Trading target background usually includes the company information, and also the trading sectors and historical financial performance overview. So those things are the general information for the trading tasks. And the second module is the action module. So this is the solely part of the manager. The manager agent is going to be conduct trading actions by using this action module, and it also can it also can reflect the reasons and analyst agent's contribution assessment. Okay, so this is the action module. And the profiling module, this can record some, the agent personnel information, agent personnel. So you give some, personal introductions and the risk performance, risk preference introductions, and record those information into the profiling module, Okay, and also there's a perception modules. So the perception module means the manager agent and an analyst agent can perceive the market information and also the investment insights from the market and from the analyst, and then it able to send some feedback. So this is like the eye and the ear of the human, just like and finally, the most important part, memory module. So I need to specially thank to the Hao Hang's efforts. So he is mainly responsible for building this complex module. Okay, so for the memory module, the manager agent has three types of module, three types of memory. The first is working memory, and the second one is a procedural memory, and the third is episode memory. So an analyst only preserve the working memory and procedural memory because the manager agent is the only one who is able to do the reflection over episode. So that's why he or she is the one has this episode memory. So this episodic memory can store the trading trajectory history. And here, so now we move to the experiments results. So for the single stock trading, we introduced, we include the 6 stocks. So the choice for those stocks is mainly based on the data source availability. As you can see, we use the cumulative return, Sharpe ratio, and the maximum drawdown as the performance criteria. And as you can see, FinCon outperformed all those models on these 3 stocks. And we actually compared the FinCon's behavior performance with the buy and hold market structure. So basically, buy and hold can represent the market, and also with other language model-based models like the generative agent, FinGDP, and the FinMan, and also the FinAgent. And also we compare the performance with the deep reinforcement learning-based algorithms like the A2C, PBO, and the DQN. So, as you can see, the red part, the red results represents the first one of all these trading texts, and the blue one represents the second one of the performance. So as you can see, all those models, they cannot has a robust performance on the trading texts, and we believe our design provided the FinCon with a very robust performance. Okay, and for the portfolio management tasks, we actually due to the limited window context, we only deal with a small portfolio. So this portfolio has only 3 stocks like Tesla, Microsoft, and the PFE. So we compared those portfolio performance with the mean variance portfolio strategy, which is a classical one in the finance. And also we compare those with the FinRL A2C algorithms, and also this equal-weighted ETF. So the equal-weighted ETF represents the markets, just like the buy and hold in the single stock trading texts. So as you can see, the FinCon also achieve impressive results. So this is for the portfolio management tasks. However, we also do the ablation studies on the risk control component. Okay, so the first the first study we test the FinCon's ability to control the risk within the episodes using the conditional variable risk. And we compare, for the single stock trading, we compare its performance on the Google and the NEO. So the Google basically represents a bullish market condition, and the NEO represents the bearish market condition. So as you can see, with and without CVAR, the FinCon can perform dramatically different. So which shows this CVAR mechanism is actually has a very effective functional. And also for the portfolio management, we use this old portfolio, and as you can see, with or without CVAR, the FinCon can perform very differently. Okay, so which means those conditional variable risk can actually control the risk. Okay, and the second part, we also test the over episode risk control mechanism in FinCon. And so here we choose to, so we consider two cases, like the updated investment belief or not updating the investment belief. So for the single stock trading, as you can see, so this belief update process is very essential for the trading tests. And also for the portfolio, we get the same results. So these two ablation studies shows our risk control component actually can help the system control the overall risk and achieve better trading performance. Okay. So in conclusion, the FinCon is a very novel LLM-based multi-agent framework for financial trading tasks, and it can deal with both single stock trading and portfolio management. And also, the FinCon has a synthesized manager-analyst hierarchical communication structure and a dual-level risk control component. And also, the manager agents synthesize the insights from the specialized analyst agents. And the final bullet, the most importantly, the dual-level risk component introduces a new approach to defining agent personas and enable dynamic updates of systematic risk management and the market belief within the agent communications. So I think that's all for my presentation. So thank you.